What is up everyone, welcome back to this second exclusive Patreon tutorial, and in today's video I will show you how you can make an archery VR game with the Steam VR plugin. So without further ado, let's get started. Okay, so I'm here inside Unity, and as you can see I've already downloaded two things, the Steam VR plugin and this Temple collection pack from opengameart.com, which is some modular 3D models that are public domain, so you are free to use them as you wish. So to use the modular pack, you can see that most of the 3D models are cut into three pieces, top, middle and bottom model, which can be changed. So for example, to make a pillar, I can drag these three things. And to make a wall, I can drag those. And here we go. Now what's left for us to do is have fun with this model and build our level from it. And here we have it. After some times you can see the final result. So I've made a huge door on this side and on the other side two big staircases. So the enemy will spawn on this side and will try to pass the door, and the goal for the player is to shoot them before they attain the door. Also you can see that I've added some props here and there, like the flags or the rug, which was also in the Temple collection pack. I think it fits nicely the atmosphere of the scene. Okay, now for the mood of the environment, I will decrease the lighting from the directional light. Then we can create a custom skybox by creating a new material, then setting its shader to procedural and tweaking a bit the parameter, and now we can drag the material to our sky. And here we go, it looks much better like this. Also, I've added in the scene this torch that were integrated in the Steam VR plugin. I've added also a point light to them and placed the torch around my scene. Now for the final touch, we can bake the light to optimize a bit better our game. So for this I will set our environment to static. Then I will add a reflection prop to make the reflection a bit better in my scene. And finally, we will go in the lighting inspector, change the skybox reflection to this gradient, which I really like, and click on bake. And here we go, the baking is done. I'm super happy with the result. I think we did a great job with the asset and the mood of our game. And you know what's the best thing after making a scene? It's to actually see it in VR. So now let's work on our VR setup. First, I will delete the main camera and add the player prefab from the Steam VR plugin. We can also reposition the player prefab a bit better and put it above one pillar, for example. And here we go. If we tried our game, you can see that already VR is working and I'm able to see my hands in the game. But if you've watched my Ultimate Steam VR guide on my YouTube channel, you know that I really prefer the other hands from Steam VR. So I'll go here under the player in the left hand and right hand game object, and we will change the render model prefab to be this one. Much better with this. Now that we have good hand, let's add our bow and arrow game. So we will be using the bow integrated in the Steam VR plugin, which is really good, and I'm not exaggerating. So to do this, we could drag in our scene the longbow prefab and the arrow prefab as well and attach them directly to our hand. This would work, but there is one big design issue with this. What if the player wants to hold the bow with the other hand? It wouldn't work, right? So to get around this problem, we can actually force the player to grab the bow before using it, so that without him knowing, he will use the bow with the correct hand. And now I will show you how to make that. First, let's remove the longbow and the arrow prefab. Then we will search for the longbow preview and add it in our scene. This game object is simply the 3D model of our longbow, nothing fancy here. Now we can first add an interactable script to it, then the item package spawner component. So as the name of this script suggests, what this script does is attach an item to the hand of the player when he interacts with it. And this is what we will be doing for the longbow. Now we can search in our project for longbow item package and drag it in the item package variable slot. So this longbow item package is just a prefab in our project, which contains only one script with some data on the item to spawn. As you can see, when we will interact with the preview longbow, it will attach on our first hand the longbow and on the other hand the arrow hand. And here we go. Now if we press play, you can see that it works. When we approach our hand, the longbow directly attached to the corresponding hand, and I can even change it by approaching my other hand. Okay, now let's tweak a bit the parameter of this script. So we can force the player to grab the preview game object here by checking require grab action. And if we want to make the preview game object disappear once we grab it, we can check the take back item and disable the preview game object here in the pickup event by calling the set active false on this game object afterwards. And here we have it, we can choose how we want to grab the bow, and now you can see how good it is. So it's really simple to use it. You just have to approach the bow with the arrow, and you can see that it will snap to the notch of the bow. And finally, if we use the index trigger button, we can stretch the rope, and when we release it, it shoots an arrow. How awesome is that, right? And here we go, we now have our bow working. Now what I want to do is actually permit the player to teleport himself to another pillar. So to do this, let's create a new 3D sphere. We can change its material to this one, which I think looks pretty good. Now let's add a new component to this sphere that I will name teleportation sphere. So in this script, I will first add using valve.vr and using valve.vr.interaction system at the top. Then we need one variable for the position we want to teleport to and one variable for the length of the fading, because yes, we want to fade the screen when we teleport. So when the arrow collide with this sphere in the onCollisionEnter function, we will start a teleportation routine. So first I will fade the screen to black for a duration of half the fade duration variable. Then we will wait for the screen to fade and then teleport the player by setting the position of the player to our destination. And after teleporting, we can unfade the screen by calling SteamVR fade with color.clear. And here we go, it's as simple as this. We simply need to add a destination now. And to do this, I will create an empty game object as a child of the sphere and put it on the top of the pillar like this. And now we can drag it in the script we just made. And here we go, now you can see it is working. When we shoot the sphere with our arrow, we fade and we teleport to the next sphere. But there is still one issue, as you can see, we need to disable the sphere after we teleport on it. So let's go back to our script and fix this. So the first thing I'm going to do is create a new variable called current sphere, which will be the current sphere we use to teleport. And this variable will be static because I want it to be the shared variable between all teleportation sphere. So now after teleporting the player, we can activate the previous sphere we used to teleport and set the current sphere to the one we used and then disable it afterwards. Oh, and by the way, we need also a default sphere which will correspond to the initial position we have. So for this, I will add a boolean variable called isInitial and set it to false. And if the sphere is initial, we can set the current game object to be this one and disable it like this. Oh, and another thing I forgot to mention is that we can also destroy the arrow after it hits the sphere, so that it will look a bit more realistic. And here we go, now our script is completed. What's left for us to do is duplicate the sphere and put it anywhere we want the player to be able to teleport to. And finally, as the player is initially in this pillar, I will set the teleportation sphere to be the initial one. And here we have it, we can now teleport anywhere with all the sphere in our scene. How awesome is that? And what's really cool with this is that it's harder for the player to teleport to the sphere that are far from here. So we actually reward the player for making a hard shot by teleporting him further. Okay, so at the moment we've made the visual of our game, the virtual reality setup, the bow interaction and the locomotion system, but now what's left for us to do is the most important part, the enemy. And for this, we'll use a 3D model that was inside the Steam VR plugin. So in our project, I will search for Joe Jeff and drag this 3D model in our scene. And here we go, I present to you our enemy for the game. Isn't it terrifying? So the first thing I'm going to do is animate him. So I will create a new animator controller and drag it to the animator of our enemy. Now for the animation, we can search for walk animation and drag here the walk animation for Steam VR in our animator. You can see that it will be played by default. And now if we press play, our model is currently animated, but there is a bit of an issue here. The animation is in fact root based, which means that it moves our enemy away from its position. And that's a problem because we want to control the position ourselves. So to fix this, I will duplicate the animation with Ctrl D. Now to remove the root position, we can go in the animation panel and remove the root T property here. And now here we go. If we replace the old walk animation by the one we just made, you can see that it is now properly working. Okay, now next step is to make our enemy walk from one point to the other, and for this I will use nav mesh. So we can make a nav mesh in 3 steps. First, we will add a nav mesh agent component to GeoGef. Now, second step, we can go in the navigation setting here with Window, AI, Navigation, and click on Bake, and this will bake a nav mesh. So the nav mesh here is the blue terrain that just appeared, which corresponds to where our enemy can move. And actually this works because we previously set our environment to static, which include navigation static, as you can see from here, so make sure you have that on. Now for the last step, we need to add a destination to our agent. For that, I will create a new component called enemy behavior. In this script, I will use a transform variable and a reference to our nav mesh agent. Oh, by the way, for accessing this component, you need to add using unityengine.ai at the top of the script. And now we can set the agent variable at the start of the game, and in the update function, I will set the destination of the agent to be the position of our destination transform parameter. And here we have it. Now let's save and go back to Unity. To set up our destination, we can create an empty game object for the destination position and drag it in our enemy behavior script. And now if we press play, you can see that our enemy is now moving towards our empty game object and everything is working fine. But obviously you have noticed that we have some tweaking to do, so let's do this. So first I will reduce the speed of our nav mesh agent to 1 and increase the angular speed. For the nav mesh itself, we don't want our agent to walk past this wall and this pillar, so to set an object as an obstacle for the nav mesh, we can go back to the navigation settings. We will click here on object select, select the object we want that have a mesh renderer and set it to non-walkable. So yeah, maybe the quicker way to do this is to select all the object mesh renderer here and set them to not walkable. Then we just select the ground, the 2 stairs and the rugs and set them to walkable. And here we go. Now if we hit bake, you can see that our nav mesh seems a bit better, so let's test this. So for this, we can duplicate our enemy and put it maybe here on the stairs too. And here we go. Now you can see that if I have enemy on one side of the map and I put the destination on the other side after the door, they are all going to it and everything is working fine. And yeah, it's a bit terrifying too, I guess. But yes, that's why they are called enemy. Okay, now that our enemy walk, we want them to die too. So for this, I will use this animation which is integrated in the 3D model of GeoGef, and we can drag it in the animator panel. And to trigger this animation, I will make a transition from any state to this animation, which will happen if the boolean value dead is set to true. So now what's left to do is set this boolean variable in our script. Okay, so let's open the enemy behavior script. I will create a new function called apply damage. So you won't be able to know this by yourself, but this function is actually a function called by the arrow when it hits an object. So as you can see, we can go and search for the arrow script in our project, and there you see that when the arrow collide, it will indeed call this function on the object it collides with. So now in the apply damage function, what we want to do is first stop the nav mesh agent with agent.stop equals true, so that the enemy will stop moving. And after this, we can access the animator which with the get component and set the dead boolean value we made to true, and this will trigger the death animation. Also, we can destroy our enemy after some time using the invoke function, which will call the destroy this method after 2 seconds. Oh, and obviously, if we want the apply damage to trigger, we need to add a collider to Joe-Jeff. So let's click here and add a sphere collider, which we can reposition with the offset parameter and change the scale with the radius parameter. Now, if we press play, you can see that if we shoot an enemy, it stops correctly, play the fall animation, and after 2 seconds, it dies. Nice! So our game is almost finished now. What I want to do is spawn the enemy infinitely. So for this, I will first remove all enemy but one that I will name Joe-Jeff Nave Mesh. We can drag him in our project folder to make him an original prefab. And now we will spawn him infinitely. So I will create an empty game object called spawner and add a new component called spawner to it. And in this script we will need a game object variable for the prefab we want to spawn and 2 float variables, one for the next spawn time and one that will count the time between 2 spawn. So now at the start of the game we can set the next spawn time to be a random value between, let's say, 5 and 10 seconds, and in the update function we can update the timer with timer plus equals time.delta time, and if the timer is greater than the next spawn time, we reset the timer. We compute again the next spawn time and we can now instantiate our prefab with the instantiate function at the position and rotation of this game object. Also, don't forget to set the enemy's destination of the prefab we spawned, otherwise it will not move. And here we go, now back in Unity, we can drag as the prefab variable the prefab we made of our enemy. And let's make our game harder by duplicating the spawner or game object and putting it at the different position, like here on top of the stairs or behind the big walls over there. And now if we hit play, you can see that enemies are spawning and moving towards our destination. Awesome. And we can even fight them, so everything is working well. Okay, now for the cherry on the cake, the last thing we need to do is make the player lose if he let too many enemies pass the door. So to do this, we will add a cube here, which I will remove its mesh renderer and set the box collider to trigger. And now inside a script attached to this cube, we will count the number of enemy with onTriggerEnter function. So when something enters the trigger zone, if the tag of the game object that is entering is an enemy, we will increment a counter variable, and if the counter is bigger than, let's say, 3, we will reset the game. And for this, the best thing to do is first to destroy the player instance that we can access as always by using valve.vr.interactionSystem, and then reload the scene by calling unityengine.scenemanagement.scenemanager.loadScene0, and here the 0 is the build index of this scene. Okay, now back to Unity, we have to set up some things to make this script works. First, we need to make sure that this scene is at build 0. Then, for triggering the onTriggerEnter function, we need to add a rigid body to the enemy prefab, which I will set to kinematic. And finally, we need to create a new tag called enemy by going here and assign it to the enemy game object. Oh, and last but not least, don't forget to click on override once you've updated the prefab. And here we go, now if we press play, our game is over. We can fight these monstrosities with our bow. We can move from pillar to pillar, and if too much of them goes through the door, it's game over for us. So I hope that you enjoy watching this fun little project using SteamVR. Anyway, today is actually ThankYouPatrons Day, so I would like to take the time to thank you for being all here at the beginning of this channel and supporting through Patreon, and let me know what you thought about this tutorial, and if you have any suggestions, don't forget to leave a comment below, or you can even contact me directly on Discord. It will be my pleasure to help you. Anyway, thank you for watching this video till the end, and see you in the next one.